All right, welcome to the second section of this tutorial. And here we have another question in mind. And don't forget the people I spoke to who are going to attempt to solve question 5, please get ready, okay? Let's get the board clear. Let's leave these guys. So if I ask you, which of these do you belong? Which of these do you belong? Now, which of these people do you belong? Do you think you are? The third one, which is the red. Oh, really? No, you know something. What about you? Which of these do you belong? Which of these do you belong? The red, just say the color. So, for you to say you are the red means you already know that you don't know. So that takes you a bit higher. It's good when you find out that this is you and this is you. It's good. Anyway, so we have a setup in next question. And the setup is like you have a cyclotron, and it has a shape of a 2D. We have the magnetic field created on this side. This is North Pole, this is South Pole. A magnetic line of force, magnetic line of force goes from from North Pole to South Pole. So we have this North, South. And there's a space here, D, where there is an accelerating electric field. Accelerating electric field. And then you're supposed to have a particle here of same mass m with a velocity v. And what it does is start from here and it's moving in this trajectory, creating a radius as it goes, with velocity moving until it comes out. Here you inject the electron. See here, see electron injected. Electron injection. By the time the electron moves in this part, and it's accelerated, because you are pumping and accelerating. Look up, guys. You are pumping this series expression. You put a charge here, mass m, q, mass m, velocity v, and then you pump and accelerating electric field. The electric field is coming through this space where it combines sort of with a magnetic field, and then it's pumping a potential into this, and then this is accelerated. By the time it comes out with a what? Highly energized electron. That's what you get here eventually. So it's called a particle accelerator. You want to accelerate a particle such that by the time it comes out, comes out with a high velocity. We have that number 7. And the first question is saying that what is the initial velocity of the particle before it enters this upper part. So let's call this the upper part, and this is the lower. What is that velocity at that point? We can say that velocity, the kinetic energy of that particle, is equal to the potential, because there is a potential difference. And this potential, we've done it, is this. In this case, this is equal to this. Then V1, therefore, is equal to 2Q V0 over n squared. V1 equals to square root of 2Q V0 over n. So this is the first velocity. The second is, as this particle is now being accelerated, can we find the radius? The radius of the coverage. And we've done radius today to be mv over q b naught. But here, let's call it r1. That is v1. So that is m, put v1 here, square root 2q b naught over n over q b naught. This becomes what? This is q. So there is one root q here. This b naught, if you bring it inside, it must be b naught squared, so that when you bring it outside, it's b naught. Here you have 2. One q has cancelled q, so you have this is mn, so this is b naught n, right? Yeah. Do you understand this mathematics? Are you sure? It's easy. If you don't understand, let's break it down. If we want to break this down for you, this R1 is the same thing as root n times root n. Root n plus root n is 1n. This is root q times root q b naught squared. Then you have this. One of this cancel one of this. One of this cancel one of this. Combine the rest. You have what you have there. Okay. So the third question is, what is the time taking? What is the time taking as it continues to move? Here our time t1 is pi r1 over v1. So we substitute these two expressions. Pi, what is I? I is 2 v naught n over q v naught squared times v1. v1 will be what? Root n over 2q naught, this. So this becomes pi. These two cancel this. You have v naught cancel v naught, you have n over q v naught. You have this. It's your time. Right? What is the second question? What's the next question? Please tell me. This is ABC. What is D? Question D is what? Please look at your notes. Tell me question D. Question A, question B, question C. What is question D? Please read it out. Read that question D.
Leaving the gaps the second time. What is the particle's velocity, trajectory, radius?
So it's like it has gone, it has come back. The second time it's going. So we need to look for the second velocity, that's V2. V2 now will be half mv2 squared equals to, because an initial kinetic energy has been used, so it is this plus q v naught. This becomes v2 squared equals this cancel this, v1 squared plus 2q v naught over n. And then v2 becomes square root of v1 squared plus, look at this. This is exactly v1 squared, right? So this is v1 squared. That means v2 equals to square root of 2 v1 squared. v2 equals to square root of 2 v1. Let's promote this to calculate R2. R2 will be what? What is R? mv over q v naught. So that is m v2 over q v naught. This becomes m root 2 v1 over q v naught. Right? Yeah, this is root. This is no. Sorry, don't get it wrong. What is R? This is R, right? Right? So the expression is wrong. So if this is R1, yeah, of course we can even start with this m v2 over q v naught. So indeed that is root m v1 over q v naught. So all of this is this, and that gives us this, right? So that becomes what? That becomes root 2 times 2 v naught n over q v naught squared. Then R2, root 2 times root 2 is what? 2 V naught M over Q V naught squared. And yeah, right? Is that so? Let's look at it. V2 is this, and then which is this, and then this is this. Yeah, that is correct. So we have this. We have this and this. Or we can basically, from here, we can basically say it's this. Right, because this is R1 and this is square root of this. In that case, what is T? T2. T2 equals to pi R2